Well, hello 1P, and we're carrying on today with our topic of partial variation. Our last lesson was on direct variation. Now we're going to learn what partial variation is. And so our goal today, I can tell the difference between direct and partial variation situations, and I can make equations and solve problems of each type. So we're going to be working on direct and partial and how to recognize those situations. So I'm going to go through a couple of examples today that have partial variation in them, and then we'll talk about what the difference is between what we're doing today and what we did in the last lesson. So partial variation, let's have a look at this situation. This is taken straight from your textbook. We're going to have a look at this type of relationship. It says Carlo works for a car sharing cooperative. The co-op owns a few cars. Co-op members can arrange to use the cars by the hour, day, or the weekend. So here's how they pay for it. The total cost here, this is the little situation. The total cost is based on a fixed cost. So you pay for having the car at all, and then you pay a little bit more depending on how far you've driven. Now that kind of makes sense. You pay a fixed cost if you want the car, and somebody else isn't using it, so you still have to pay for that car, even if you don't happen to drive it anywhere after you've rented it. And then the distance that you've driven, it would make sense for someone who has driven it longer to have to be charged more because there's more wear and tear on the car and all that kind of thing. So those are the reasons why we have things where there's a fixed rate and a cost per use type of idea. So it says the co-op pays for gas and other expenses. Carlo prepared a table to show the total cost of the car for a day. Now this is just for one day. It can be rented by the day, the hour, or the weekend, and so there's a fixed cost depending on it. So this is just for the day. So we're going to take a look and see what patterns we find in the table. This says some parts of the table are blank because coffee was spilled on it. So this part of the table, we don't know what it is. We're going to have to fill it in. And here's the things that we're looking for. We're looking for what patterns do we see in the table? Can we figure out what the fixed cost is and what the kilometer per kilometer cost is? Can we graph the data? Can we write a rule for how we calculate the total cost if we know the distance driven, and write an equation with math symbols and letters in it. Okay, so let's have a better look at this situation. This is the table a little bit bigger, and we're going to see if we can find the patterns in the table. So what kind of patterns are we looking at here? Well, the first pattern I see is that our distance driven, they didn't go up by 1 kilometer because that would make a really big table. So they've gone up by 10 every time. So the change in the distance driven is going up by 10. How about the change in the cost? When the distance driven goes up by 10 kilometers, how's the cost changing? Well, from $49 to $50.50, that's $1.50. And from $50.50 to $52, that's $1.50. And from $52 to $3.50, that's $1.50. So it looks like this is changing by $1.50 for every 10 kilometers driven. That's what this is saying. So now we can follow this pattern backwards. Blam! There we go. Through the magic of video, it's right there. I followed that pattern backwards. I went backwards. I subtracted $1.50, and then I subtracted $1.50 again, and I subtracted $1.50 again, until I got all the way down to the last entry here. This one that has a 0 and a $40. So what this tells us here is that if we've driven 0 kilometers, we still have to pay $40. Now this, my friends, is called the fixed cost, because it doesn't matter how many kilometers you drive, you have to pay that $40. Okay? Even if you don't drive anything, you have to pay that $40. So what patterns do we see in the table? Well, we see that the distance goes up by tens, distance, and we're going to call that the change in distance. So I'm going to use that little symbol, that triangle that means change in. Change in distance is 10, and the total cost, the change in cost, so we'll call that the change in C, is $1.50. Let's actually call this the distance. We're going to say that that's going to change N, because we're going to call the number of kilometers driven N. So let's actually graph this. Now, what goes where? Does cost depend on how far you drive it, or does how far you drive it depend on cost? Or in other words, what's set and what do we calculate? Well, I hope you see that this is set. The distance driven is set, and then we have to calculate the cost. So we have to go from 0 to 100 along this side. And I'm going to start at 0 here. How many spaces do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a little bit more, but not enough to make each one of these like go 2 spaces for 10. So I'm going to say that that's 10, 20, 30, 40, 50, 60, 70, 80. Whoops, that's not an 80. 80. 90, and then that's 100, and then this would be 120 here and 140 here. Okay, so we go up to 140 on here, and this was the distance driven because this is what we set. So the distance in kilometers is what is set, what we know, and then the total cost is what we have to figure out. So the cost has to go up to 55, and it has to start somewhere around 40. So I'm going to put a little jog here to say that we're not quite starting at 0, and we have to at least start at 40. I'm going to start at 35, and how do we get to 55? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I take a look, I need to go from 40 to 55. So that's $15, and I got 15 spaces to do it. So I can make each of these spaces be worth $1. So let's call this one down here $40. So we'll start it right at 40. And then we'll go 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. Oh, we didn't quite make it, but we'll leave it there. Okay. We could have made each one of them worth 2, and then we could have got up farther. All right, so let's graph these points. Ta-da! There it is. There's all my points on the graph. Well, actually, it's not all the points. I only graphed the nice ones. I graphed the 20s and the 40s and the 60s because they were nice. They didn't have a 50 cents after it. So I only graphed the ones that were really nice. And notice that I put a line through it to show that there was this relationship, but I put a dotted line through it because not absolutely all of that information in there is useful to me. I'm pretty sure they're not going to charge you for like a half a kilometer or a quarter of a kilometer. They're going to round to the nearest kilometer. So to get the cost, you won't be able to get all the different costs in there because they're not going to charge you for small amounts. So here's our graph. Now let's see, what does this say? What is the fixed cost? Well, we already figured that out, that $40. What is the cost per kilometer? That sounds like a unit rate to me. We want cost per kilometer. So let's take a look here. We know that every time we drive 10 kilometers, our cost went up $1.50. So this is considered the change in Y. This column is how our Y changes, or our vertical axis changes, and this column is how our X changes. And remember when we were talking about unit rate before, we found the rate of change, our ROC, is the change in Y over the change in X. In this case, that's $1.50 divided by 10, which means that our rate of change is 0.15 or 15 cents. So the cost per kilometer is 15 cents. So for every kilometer you drive, you're going to pay 15 cents. Write a rule to calculate the cost when you know the distance driven. Okay, if we know the distance driven, let's take up here. What do we have to do? This says cost depending on distance driven. So we need to take, we know it's 15 cents, so we need to take 15 cents times the number of kilometers. So that will give us how much for our distance driven. This is for distance driven. That's our cost. But then we also have to add to that the fixed cost, which is $40 for this particular situation. So this is a rule to calculate the cost. We have the fixed cost, and then we have to add in the little bit for how far we've driven. So if we're going to write an equation for that, let's let C be total cost. And then how do we do 15 times the number of kilometers? Well, it told us that we're using N for the distance driven in kilometers and our C. So there's our two variables. So we need to do 15 cents. I'm going to write that in dollar form, 0.15, times the number of kilometers. Well, this tells us the number of kilometers. We're going to let be N because we don't know it. And then we have to add in the fixed cost, which is $40. Use your equation to find the cost of driving 550 kilometers. So here's how we do that. We're trying to find C, so we're going to leave that as C. But I know that my N is 550 kilometers. So I'm going to replace that N with 550 and then add 40. Now remember your order of operations. We have to do this multiplication before we do that addition. So I'm going to do 0.15 times 550 equals 8250. 8250, and then we have to add that $40 onto the end. So that is $122.50 is what it would cost if we drove 550 kilometers. So we got a lot of information out of here. Let's take a look at another example. The cost of printing a yearbook is $5,000 for the initial setup and production costs, and then $10 per book ordered. Make a table of values and graph this relationship for 0 to 400 books. Well, we're going to start with the number of books because that's what I'm setting. I'm going to set the number of books. I have to go from 0 to 400. So I'm going to start at 0, but I'm not going to go 1, 2, 3, 4. That's silly. I'm not even going to go 2, 4, 6, 8. That's silly. I'm going to go by hundreds, I think. 100, 200, 300, 400. And over here, this is going to be the cost. And so the cost of printing 0 books, it tells us that here, even if we don't order any books, if we have to set it up and put it together, we owe them $5,000. And then it says it's $10 per book. So here we've ordered 100 books. So 100 times 10 is 1,000. So I have to add another 1,000 on here, which is 600 or 6,000. Now for 200 books at $10 a book, that's $2,000 that I'm adding on to that fixed cost. So another $2,000 onto 5,000 is 7,000. And you can take a look here. You can see the pattern now. I'm just going up by 1,000. So the next one is going to be 8,000 and then 9,000. Now, how do I put this on this graph? Obviously, I've got some thinking to do about this. First thing is what goes where? Number of books and cost. Well, the number of books is what I fixed. So since this was what I knew, what I set, it goes on the bottom. So this is going to be our number of books. And I need to go from 0 to 400. Well, let's start it at 0. And then that, to get to 400, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 spaces to get to 400. So let's take a look. 400 divided by 15 is 26.666. And we're going to round that up to something nice. I'm maybe going to make each of these spaces be 50. Okay, that's a big round up, but 50 is really nice to work with. So I'm going to let this be 50, which means every two spaces is 100. So that will be 200. That would be 300. That would be 400, 500, 600, 700. Now, up the side for cost, I'm not going to start it at 0. I'm going to do a little jog here, and it has to start at 5,000. So I'm going to start this here, 5,000, and I have to get up to 9,000. So would I go 5, 6, 7, 8, 9? That's leaving a whole lot of space blank. So to get to 9,000, I'm going to go 5. Let's make this one 6,000. Skip 1. 7,000. Skip 1. 8,000. Skip 1. 9,000. There, that's got me up to 9,000. And I've still got a little bit of room here, but that's okay because I had a little bit of room over here. So I'm going to call this one 10,000 and 11,000. And then the very last at the top is 12,000. So up the side, this is total cost. And this is in dollars. So let's put our dots on. And there we go. I put 100 books at $6,000 and so on and so forth. Now again, I've joined it with a dotted line because while there's a relationship and there's numbers in here, like I can order 50 books in between those 2 points, or I can order 75 books that would be in here, but not all of the information is valid because I can't order half a book. So not everything between 0 and 100 works because I can't order 50 and a half books. So that's why I put the dotted line. So what is the fixed cost? Well, the fixed cost was that initial thing. We were told it right up here that the cost of printing and setup and stuff like that is $5,000. 0 books cost $5,000, and right there on our graph, right at the beginning where the 0 is $5,000. So our fixed rate, our fixed cost is $5,000. Where is this on the graph? Right on the vertical or y axis. If you start this at 0, which you should. And what is the rate of change? Well, the rate of change, it's easier to get from the table than from the graph, although the graph's not too hard. From the graph here, let's draw a triangle on here. If I draw that triangle, remember our rise and our run, because the rate of change equals rise over run. Okay, so our rise here, we went from 6,000, this point here is at 6,000 and this is at 8,000. So our rise is 2,000 and our run goes from 100 to 300, so that's 200. So 2,000 divided by 200 is 10. Okay, so our rate of change is 10. And we could have got that from this table too. If we take a look, this goes up by 1,000 every time we go up by 100. So this is known as our change in y, and this is known as our change in x. So the rock is the change in y divided by the change in x, which is 1,000 divided by 100, or 10. If you let the number of books ordered be n, write an equation for the cost of producing n number of books. Well, we did that up here. We know that each book cost us, so what did we do up here? We took this $10 per book and multiplied it by the number of books. And then when we were done, we added that $5,000 on there. That's what we were doing every time. So we took the number of books that we had, And then we multiplied it by $10 a book. And then we added on the initial cost of $5,000. And that got us the cost of printing the books. And so you see this, and this is coming up again and again. This is the rate of change, and this is the initial value, the beginning value. So if we take our n, which is our let's take that. Our n is our independent variable. So what this says is that our dependent variable equals the rate of change times the independent variable. I'm not spelling that right. Independent. And then we got the initial value. So this shows partial variation. The cost doesn't vary directly with number of books ordered because we have that fixed cost in there. So the fixed cost is the key for partial variation, no matter how many books ordered. So here's the properties of partial variation. Maybe. Oh, there we go. Linear. Hold on. Okay, I got these in a funny order. It's linear, forms a straight line. Second one, it has some sort of fixed value as well as the cost per item. What else do we have here? This one. It does not start at 0, 0. Like yesterday it started at 0, 0. It starts on the y-axis at the fixed value. We'll call this the vertical or the y-intercept. And last, you can use the same method for rate of change as you did in direct variation. So I want you to compare these two, and I'm going to come around and see how well you did. I want you to tell me what the graph looks like for direct variation, what the graph looks like for partial variation. I want you to tell me what the equation looks like for direct variation and what the equation looks like for partial variation. And I want you to tell me what the relationship is for direct variation and for partial variation. And so you need to fill that out yourself, and I'll be talking to you about it. And that concludes this video.